Good evening, everyone. We are in the week 7 problem solving session of the NPTEL course Basic Electrical Circuits. And week 7 is about two-port networks and reciprocity in resistive network. Let me share my screen. Yeah, so today we'll be starting with the two-port network. In the last week, we have only seen about Y parameters. Today we'll discuss about few more parameters like Z parameters, H parameters, Z parameters, and we'll see how they are defined and how we can calculate them in a given two-port network. And then we'll see for a circuit to be reciprocal, what is the condition that the circuit has to satisfy? So using that condition, we'll solve few problems so that we'll see how we can deal with the two-port network. So today I'll start with first Y parameters, which we have already discussed last week. So I'll just briefly give some introduction about the parameters. So we'll know what those parameters are and how they are defined. Then we'll complete the introduction about parameters and we'll solve or we'll spend more time in doing problem solving session because I have seen that these problems are not so straightforward and they're little bit tricky and lengthy. So I would like to spend more time so that you will do better in the exam. So first we'll start with Y parameters. I hope you are able to see my screen. Can you please confirm if you are able to see my screen?
Yes, sir.
Okay. So this is the network and the voltage and current polarity are defined in this way. So you just see how they are defined and they are defined the same way. Sorry, throughout this entire course. So we have two ports. One is a port one and another one is port two. So on the port one, we have one dash and two dash. So this plus minus is the voltage at port one and this plus minus is the voltage at port two. And in both the sides, currents are entering. So we always consider I1 and I2 are entering. Maybe they could be in a different direction. Then we'll get a negative sign, but this is how they are defined. Okay. So how they are defined? So Y parameters are defined something like this. So their output parameters are I1 and I2. Okay. And we have Y11, Y12, Y21, and Y22. So these are the parameters multiplied by the input voltage V1 and V2. So as this is a linear circuit, we can write the voltages and currents in a linear combination form. So I1 can be written in terms of V1 and V2, and I2 can also be written in terms of V1 and V2. So if we consider it in a matrix form, then we'll get a matrix something like Y11, Y12, Y21, and Y22. So now this matrix is called the Y parameter matrix, which is also defined by Y. So in the case of Y parameters, outputs are currents and the input are voltages. So now if I define Y11, Y1 individually, we'll get something like that. So Y11, so how will I get Y11? If I keep V2 to be 0, then I1 by V1 is Y11. So I'll get I1 by V1 when V2 is equals to 0. So this is my Y11. Similarly, how will I get Y12? So we have to see what is the multiplying voltage with that parameter and the other voltage we have to make it 0. So we'll get something like I1 by V2 when V1 equals to 0. Similarly, if I check now Y21, I'll have something like this I2 by V1 when V2 is equals to 0. And if I check Y22, I'll get something like this, which is I2 by V2 when V1 equals to 0. So this is how I'll be getting. So in order to solve this, so Y11 and Y21 can be obtained when V2 equals to 0. So once I short on the, if this is shorted, then if I calculate V1, I1 and I2, then I'll get Y11, which is I1 by V1 and Y21, which is I2 by V1. Similarly, if I short on the primary side or say port 1 side, which is V1 equals to 0, then I'll get Y12 and Y22. So in order to calculate this, first I'll make V1 equals to 0. Say this is shorted. Then I have three parameters that needs to be found, I1, I2 and V2. So I have to find the ratio to get the corresponding parameters. So is this clear? until this point, how they are defined? Any doubts? Yes, sir. So this is called conductance because it is the current in port 1 and voltage in port 1. So this is conductance. And this is transconductance because it has voltage in one port and current in the other port, transconductance. Okay. So if this is transconductance, what happens to Y21? So that will also be transconductance. So this is also transconductance because it has one voltage of one port and current of another port, and this also becomes conductance because it consists of voltage and current from the same port. So is that clear? How by the those names? So today I'll just give some introduction about these parameters so that there will not be any confusion and I can use them for the further explanation or during problem solving session. I hope it is clear till this point. So now we'll move on to Z parameters. So now we have Z parameters. As the name says, Z means it is resistance or you can say impedance. So voltage will be the output and current will be the input. So let me just copy it so that I can use this and update for my ease. So it will save some time and also we can use that time in the problem solving session. So this will become my V1 and V2. So this is my V1, V2 because it is impedance. We know that the ratio will be voltage to current. So input will be current and output will be voltage I1 and I2. So now this will become Z11, Z12, Z21, Z22 and this will become Z matrix. So we have Z11, Z12, Z21, Z22 and this matrix is Z matrix. So is this clear? It is just exactly the same, only inputs and outputs are different. Is this clear until this point? Yeah. So if you have any doubts, you can ask me. Don't keep the queries to yourself. I hope it is clear. You can just mention in the chat box if it is clear or uh, any.
Yes.
Yeah. Okay. So now let us define Z11 and Z12, how we have defined Y11 and Y12. And this definition is very important because in the experiment, sorry, in the assignment, they'll ask what is Z11. So you have to understand that it is V1 by I1 when I2 equals to 0. So we need to know this because in the exam, they will not define what is Z11, Z12 because they are already defined by sir. So we have to follow the same convention and it is the same for like in any university, they everyone follows the same convention Z11, Z12, everything. So now if we do Z21, it is V1 by I1 when I2 equals to 0. And this will be Z22, which is V2 by I2 when I1 equals to 0. So if you see, it's the again the same case. This happens when I2 equals to 0, which means it is open circuited. That is when the current will become 0. This is also I1 equals to 0. That's when I1 will be 0. So in the left case, the right side port is open. In the right side case, left side port is open. And similarly, this is called resistance because it is voltage to current ratio, and this is called trans resistance because it consists of voltage of one port and current of other port. So that's why the name. So if this is trans resistance, then this is also trans resistance. And if this is resistance, then this is also resistance. So that's how it is defined. So if we see here, voltages are becoming zero, which means they are shorted. So that's why these are also called as short circuit parameters. Because for finding these parameters, basically we are short circuiting either at the port 1 or at the port 2. Similarly, for the Z parameters, you are open circuiting to make the current 0. So that's why this is called open circuit parameters. Is this clear until this point? I have just discussed Y parameters, which was anyway discussed in the last week, but I have just given uh, some some more definition. Any doubts, or is it clear? Okay. Yes, sir. So I hope
Sir,
yeah.
any shortcut to remember all these parameters? Anything? Because we have to remember the equations, or is there any shortcut so that
Yes,
we can
so you
remember?
have to remember this. Y parameters means admittance. So it is current to voltage. So current is the input, voltage is the output. So now once I know what is the input and what is the output, I know Y11 is I1 by V1. So V2 I'll make 0. And Y12 is I1 by V2 and V1 I'll make 0. So first you have to understand what are the inputs and what are the outputs. So for Y parameters, I know this is the matrix. So first I'll write the matrix. Then I will see what is my Y11, because once I know this, I know if I make V2 0, then I'll get I1 equals to Y11 V1. So Y11 is I1 by V1 when V2 equals to 0. So I need to remember this matrix. So the matrix is the basic thing that we have to remember. And when it is Y parameters, you know it is currents on the left side, voltages on the right side. When it is Z parameters, it is voltages on the left side and currents on the right side. So for Y and Z parameters, there is no confusion. You just have to write this matrix, and from there you will get these equations, because you need not remember, and it is also not expected to remember all of these things because it is very difficult. You just have to remember this
Okay.
matrix multiplication. From there you can define. So now if I have to calculate Z11, first I'll write this equation. Now I'll know I2 is 0. So I'll open the circuit and I'll give some voltage here and I'll calculate I1 and I2. So that's how we do. You just have to remember that equations, from where you'll write the these parameter expressions, and from there you can do. So I hope it is clear until this point. Is it clear? Whoever has asked.
Yes, sir. Yes, sir.
Okay. Now we'll discuss about H parameters. So H parameters are a little bit they are also called as hybrid parameters. Why they are hybrid? Because input is neither the voltage nor the current, but it's just one voltage and one current. So that's why it is called hybrid parameters. So the output are V1 and I2. So here we have I2. So that's why here it will be V2. Okay. So these are now again H11, H12, H22, and this will be H matrix. So first you have to remember V1, I2, I1, V2. So then what will I write? I will just write H11, H12, H21, and H22. So now I know I got the matrix. So from here, I know that this is my H matrix. So now individually I can define these H parameters from the matrix itself. How will I define? I know H11 is equals to V1 by I1 when V2 is equals to 0. So from the matrix only I'm writing. I'm not remembering. I'm looking at the matrix, and from there itself I'm writing. And H12 is V1 by V2 when I1 equals to 0. Similarly, H21 is equals to I2 by I1 when V2 equals to 0, and H22 is equals to I2 by V2 when I1 equals to 0. So again, in this case, for finding these two parameters, we have to short circuit the port 2, which means V2 equals to 0. But whereas for port 1, we have to open circuit because current is the 0 term here. So now if you see, this has a dimension of resistance, and H12 is dimensionless. Okay, maybe I'll use red color so that it will be more visible. red. So now if this is dimensionless, then this is also dimensionless because it is the ratio of currents. So now what's with the last one? Last one will be conductance because it is current to voltage. So is this clear? So first we got this definition how H parameters are defined. So we have defined input output. So from this matrix I am drawing which is what H11, H21, H12, H22. And then from there I have written what is their dimension, whether they have dimension or whether they're dimensionless or resistance or conductance. So this is just definition. How we will find that we'll slowly see while we get into problem solving session. But till now we are just only defining the parameters for a given two-port network. Any doubts or is it clear till this point?
Clear.
Clear? Okay. So now we'll go into another parameters. So till now we are just defining the parameters and we are just learning about it. So now we'll go into something called G parameters. So G parameters are the exact opposite of H parameters. What I mean to say is here the inputs are I1, V2, outputs are V1, I2, right? So here it will be just the exactly opposite thing. So the outputs are I1, V2. Outputs are I1, V2. So the inputs will become V1, I2. So this is V1, I2. Right. So now if you see, if I erase this, these are G parameters now. They are defined in this way. G11, G12, G21, G22. And then this is G matrix. Okay. So now once the G matrix is defined, now we'll define the parameters individually. So G11 will be I1 by V1 when I2 is equals to 0. Similarly, G12 is equals to I1 by I2 when V1 is equals to 0. And then G21 is equals to V2 by V1 when I2 equals to 0. And G22 is V2 by I2 when V1 equals to 0. So now if you see, again the left parameters are obtained when I2 equals to 0 and these are obtained when V1 equals to 0. If we compare it with these parameters, so if you see here it is V2 0, here it is I2 0, here it is I1 0, here it is V1 0. So because voltage and currents are exchanged, if it is voltage here and here it will be current. And now if you look at the dimension, here it is conductance and here this is resistance. Okay. So now what about the G12 and G21? They are dimensionless because it is either the ratio of voltages or the ratio of currents. So here this is ratio of currents and this is ratio of voltage. So they don't have dimension. You have to be very clear and thorough with this. So first we'll always write the matrices and from there we are going to get the parameters. First we'll write the matrix, then we'll define them and then we'll obtain the parameters individually. So now let me just summarize this entire thing. So first I have y parameters. So I'll write everything at a place. So this is like a summary. So we have a summary. So this will be our y parameters. And similarly, let me take the z parameters. So now if you look at these two, in one case, one is the input, like voltage is the input, current is the output. In the other case, current is the input and voltage is the output. So from this, we can say that Y matrix is equals to Z inverse. Because basically, if we do the inverse, then we'll get the other equation. So that's why Y equals to Z inverse. So this is a very important result, because once you calculate Z parameters, you need not calculate the Y parameters again. It will be Y equals to Z inverse. Sir, can I get old classes video? Same reason I could not attend last classes. So Chetan, old classes in the sense my recording videos, or which videos are you asking about? My problem solving session videos. Can you please mention it clear, because I'm not sure what exactly you're asking for. Yes, sir, your class. Okay. I have actually mentioned this in my earlier chat. So I'm just going up and I'll give you three links which I have given on my day one. So these are the three links I'm mentioning again in the group chat. So one is my YouTube channel where I'll be uploading all these videos. So you can go to that, go to my YouTube channel, and then you can subscribe, so that whenever I'll update the videos, you'll get the notification. And then there is a link to the Zoom meeting, which is this meeting, where I'll take these sessions every week until the week 12. So the same link will be used throughout this entire course. So you can follow this link. And the third one is the link to the drive, where I'll upload my notes. So you can access the notes from that drive. I'll also mention the link in my YouTube video, the caption or description. So from there also you can access. So keep these links saved so that you can access them anytime. Thanks, sir. Yeah. So now we have discussed about Y and Z parameters relation. Now we'll go to H parameters and Z parameters. So for H parameters, we have seen voltage, these voltages and currents are input. And for G parameters, we have seen it is just the exactly opposite. If you see one, in one case, what are the inputs? They are the outputs in the other case. Similarly, what are the outputs in one case are the inputs in the other case. So same result we are going to get here, which is H is equals to G inverse. So in the case, if we calculate G parameters, then I can calculate H parameters directly by doing the inverse of the G parameter matrix. So these two are very key results, which will save time, because in a question they might ask, find the Z parameters and find Y parameters. So if you find Y, no need to find Z again. You can directly do the inversion, and vice versa. So if you calculate Z, then you can directly get the Y parameter. So is this clear until this point? So we have discussed maybe let me just summarize quickly before we go to reciprocity. So we have discussed about Y parameters, which are also called as short circuit parameters. So in these parameters, currents are the input, currents are the output and voltages are the input, and these are defined in this way. In the case of Z parameters, currents are the input and voltages are the output, and these parameters are defined in this way. So in this case, we have two conductance and two transconductance. Here we have two resistance and two transresistance, and these two are analogous to each other, and the Z matrix is inverse of Y matrix, or Y matrix is inverse of Z matrix. And in the case of H parameters, I1 and V2 are input, V1 and I2 are input, and these are defined in this way. Here we have resistance, conductance, and two dimensionless parameters, because they are the ratio of voltages and currents. So in the case of G parameters, it is vice versa. Here V1 and I2 are the inputs, and I1 and V2 are the outputs, and these are defined in this way. So if you see here, we have resistance, here we have conductance. So here we have conductance, here we have resistance, and here we have the ratio of voltages, and here we have ratio of currents. Here we have ratio of currents, and here we have ratio of the voltages. And we can get this relationship by just doing the inverse of this matrix. So Y is Z inverse and H is G inverse. So that completes our basic intro about the parameters and all. So now, do you have any query until this point? I'm not going in detail of all the things that sir has covered, because I would like to spend more time on problems this week, because they're somewhat difficult to the earlier weeks, and it is crucial to solve problems, as for two ports there are many calculations and problems are a little bit lengthy. So we'll spend more time on problems. If you don't have any questions, then we'll move to reciprocity. Any queries? Okay. So I'll also not go into the proof of reciprocity because that sir has covered thoroughly in his lectures. So I'll just only touch upon the results of the reciprocity. So any two-port network that is reciprocal will satisfy this. So what are the conditions? So the conditions are as follows. One is Z12 is equals to Z21. As Z12, Z21, if you do the inversion of Z matrix, we'll get Y12, Y21. So it is also Y12 equals to Y21. So if you do for H parameters, you will get H12 is equals to minus H21. And because H and G parameters are like related by inversion, you will get G12 is equals to minus G21. So this is the condition that we will get. So any one of these, like all of this will be satisfied, but in order to prove, you can prove any one of them, and you will get the you'll know whether the circuit is reciprocal or not. So there or this or this or this, any one of that. So in any given circuit, if they ask whether the circuit is reciprocal, either you find any one of this. So Z1 to Z21 or Y21, Y12, H12 minus H21, G12 or minus G12. So if you check any one of these and if they are happens to be equal, then it means the circuit is reciprocal. So I'm not going into that much detail because we'll see in the problems how uh, they are getting checked and how to see whether the circuit is reciprocal or not. And proof sir has thoroughly covered, and in the assignment, not much proof related questions will be asked, but you have to know how to apply this concept in problems. So which is the main and key aspect. So we'll be going into that soon. So do you have any queries until this point? So now we can start solving problems. We have 1.5 hour left. So I think we'll be able to solve 4 problems at least. 3 to 4. Any queries until this point? If you have any queries, you can ask, not related to this or anything like how to solve if you are facing any issues and if you want to know how to improve, you can ask any questions. Don't think that whatever is taught you have to ask from that. If you have any other queries, like if you are facing issues in solving the problems in the exam or if the time is not sufficient, what to do. So you can ask any problem, any questions. Sir, how to improve solving skills? Yeah, Bhuvan. So when it comes to any mathematical problems, so the main main fundamental thing is first we have to clear our concept. So let me just go back to what I have used in my week 6. So let us go to week 6 because there I have mentioned. So I said these are the things that you should keep in mind to improve yourself. So let us just quickly go through my week 6 notes. Yeah, I said these things. So first, you always follow the lecture videos, and this is must. You cannot skip these videos. Problem solving sessions are in addition to the lecture videos. They are not the replacement of lecture videos. Don't think that by attending problem solving session you can skip the lecture videos. That is not the case. You follow lecture videos and whatever problems that sir has solved, you try to solve them by yourself by pausing the video and check how to solve and check whether the answer is matching or not. And after that, when I'm conducting the problem solving session and when I'm doing the problems, you should do with me. You should not look at the screen and see how I'm solving because you have to solve and do, and then you'll gain the confidence. And say you have solved it with me, but few problems you're not able to solve. Then after this video is uploaded to the YouTube, then you can again try to solve these problems and see whether you're able to solve all by yourself without taking much help. Then if time permits, then you can refer to other problem solving sessions because they will be solving different problems. Then you take that problem and then solve. If you are not able to solve, then you can see the video because they have explained the solution, and then you can see why you are not able to solve. By doing all these things, you will be able to solve majority of the problems in the assignment. But I understand that some problems might be tricky and you might not be able to solve in the first go. So in the assignment, say you are able to solve only 60% of the problems, then the rest of the after the keys like released, your marks are released, you try to check where you have made mistake and again try to solve that question by yourself. Like maybe you might have done some small mistake during the assignment time, or maybe you have done some calculation mistake. So first you give it a try and try to solve it by yourself. And even I can assure that once you solve by yourself, you will be able to solve at least 50% of the 50% of your mistakes. You will be able to realize. But say there might be few questions where you might not get an idea like how to proceed with that question, and it is acceptable. It is not like a mistake because there could be some questions which are tough and which are new. You might not get a thought of solving that. But as we are explaining the solution, so while we are explaining the solution, then you can see how to solve that question, and where you have made a mistake, or if you have not gotten that thought, then maybe we'll explain how to get that thought. Then you will keep that in mind in the future purpose, and in the final exam also, similar problems will be given. You can implement that same idea and you can improve yourself. Sir, got 92% in week 6. Your lectures helped a lot. Thank you, Roshan Ghosh, and I'm very glad that my lectures are helpful to you, and you got 92%, which is really, really good. And you can see where you have made mistake, and you can again give it a try and see whether you're able to solve by yourself. If not, then maybe after 1 to 2 weeks, again we'll start solving the solution for this current year assignments, and maybe at that time you can see why or where you have made a mistake. Yeah, and this is all with the assignments. And for final question paper, we'll see if I can solve or show you some previous year questions. And I would say, as the TS who will be making the assignments, they will only be making the questions. So they'll keep in mind the problems that are given in the assignment. So around 60 to 70%, you can expect similar, not the same, similar type of problems. When I say similar, it does not mean that they'll change the numbers and give the same question, but a similar model. Say instead, if they have given voltage source, maybe they could have converted into current source. Or say if they have asked H parameters in the assignment, maybe similar type they'll ask for G parameter. So almost 60 to 70% problems will remain the same, and the other 30% people will give somewhat new questions, but not so difficult, maybe somewhat conceptual and little bit tricky to create difference in the grading, because everything cannot be easy. Then if many people score the similar marks, grading would be difficult. So considering 30% of marks, they'll make it somewhat tricky, and out of those, say 70%, out of 100%, 70% will be mostly from the assignment, and 20% will be little bit tricky, and 10% they'll actually give somewhat difficult questions to actually separate that people who have really understood the concepts. Sir, let us solve problems on two-port networks. Yeah. So now it is the problem solving session. So first we'll start with the first problem. So in this first problem, they have asked in the two-port network, the circuit is reciprocal and determine Rm. So now I'll again show you question 2 and I'll show you why. In this question, they have asked if Rm is chosen, then determine the H parameters. So now why I am showing you the second question is, say if a circuit is reciprocal, I can do by 4 ways. I can calculate Z parameters, Y parameters, H parameters, G parameters. But if you see in the question, second question, they have asked H parameters. So why will I waste my time finding some other parameters here and then again find H parameters? Instead, I'll find the H parameters, H12 and H21, and then I'll use this condition, which is H12 is minus H21, and then I'll use that result and I'll directly solve the H parameters in the second question because it will save a lot of time. Okay. So now we'll start with the problem, and these two port parameters, like questions are a little bit tricky, and I'll solve it. I'll try to solve it slowly. It's not how many problems we have solved in this session, but it's how good have we solved these problems in this session. So conceptual understanding is very, very critical. So you clearly follow everything and try to do it with me, or maybe you can also try problem solving session. So in the first question, they have asked what is the value of Rm such that the circuit is reciprocal. So this is the question they're asking, determine the value of Rm. So once we determine the value of Rm, that will be used to find the H parameters. So the condition is H12 is equals to minus H21 for the circuit to be reciprocal. Okay. So this is the condition that we have to apply to find the value of Rm. But before that, I don't know what is H12, what is H21 because we don't remember, right? So first I'll go to H parameters. H parameters, what are the inputs, what are the outputs? So I'll take this result and first I'll define what is H12 and what is H22. So if this is my H parameters, then I know what is my H12. So my H12 is V1 by V2 when I1 equals to 0. And similarly, my H21 is I2 by I1 when V2 is equals to 0. Yeah. So first I will calculate H12, then I'll calculate H21, and then we'll use this expression. Okay. So first, let us solve H12. So for calculating H12, so first we are calculating H12. So for calculating H12, V1 should be 0, and we have to find V1 by V2, right? Okay. So this is the, I'm sorry. So this is the one, the question that they have given, or let me just take the only image so I can use a better picture for better understanding. Okay. So if I delete this, I will take a somewhat bigger picture. Okay. So H12 is V1 by V2 when I1 is equals to 0. So I1 equals to 0 meaning this will be open. Then only this is I1, right? This uh, current will be 0. So now this voltage is becoming plus minus V1. So we have to follow the same convention, currents and voltages. Now at the circuit 2, we are giving it a voltage V2. So because V2 is the input and V1 is the output. So I have to find V2 and sorry, I have to give the input V2 and I have to find the voltage V1. So basically at this terminal, we are giving a voltage V2. So if this is V2, then this is the direction of I2. So we have to basically find V1 by V2. We have to find voltage V1 in terms of V2, and then we have to find the ratio. So until this point, is this clear, or do you have any further doubts? Is it clear? Hello?
Yes, sir.
Yeah. So now I can directly see Ix is how much? So Ix is nothing but V2 by 1 kilo ohm, right? Because if I consider this as say if I consider this as ground, then this voltage is basically V2. So Ix is nothing but V2 by 1 kilo ohm, which means V2 into
Excuse me.
yeah,
Yes, sir.
sorry. Hello, Lokesh, are you saying something?
Light this going up.
Sorry, Lokesh.
Nothing, sir.
Okay. Okay. So yeah. So it will be V2 into V2 into 1 milliampere. So that is my Ix. So now if I know Ix, I can find this voltage V1. So my V1 is equals to Rm into Ix plus 1 kilo ohm into this current, right? Agree? Say this current is some I, say I have to use a different, so let this be I3. So Ik into I3. Agree? Or let me
Yes.
write the voltage V1 here. So this voltage is now V1. So I have written V1 because this is ground. V1 is nothing but Rm into Ix plus 1 kilo ohm into I3. So from here, I can get that I3 is equals to V1 minus Rm into Ix by 1 kilo ohm. So let this be my equation 1. So basically, I have to find V1 and V2 some relation in an equation. So now, if you see this current I2 is equals to 0 because it is open. So if it is I3, this circuit current will also be I3 because the same current, entire current will flow. So now I3, I can get a relationship between V1 and V2, right? So I3 is V2 because it's at a higher potential minus V1 by 1 kilo ohm. Sorry.
I1 would be 0 now.
Yes. Sorry. Yeah, you are right. So this is I1, not I2. Yeah, thanks for pointing out. So I1 is 0. So this current is same as this branch current. So both the 1 kilo ohm resistor carry the same current. So I got I3 from this 1 kilo ohm, and this is my equation. So now if I equate, say this is my equation 2. So now if I equate this equation 1 and equation 2, I'll be getting something like this. What I'll be getting? V1 minus Rm into Ix by 1 kilo ohm is equals to V2 minus V1 by 1 kilo ohm. So 1 kilo ohm, 1 kilo ohm will get cancelled. So from this I'll get 2V1 is equals to V2 plus Rm into Ix. Okay. But I also know Ix. Ix is V2 into 1 milliampere, right? So V2 into 1 milli. So from this I'll get 2V1 equals to V2 plus Rm into V2 into 1 milli. So Rm into V2 into 1 milli. So now from this I can get my parameter, which is what I want, H12, which is V1 by V2. So now my parameter that I was trying to find is V1 by V2 when I1 equals to 0. It is given by, what is it? It is V2, so it is 1 plus Rm into 1 milli by 2. Fine. Everyone agree? So it is not H11, it is basically H12. Agree everyone? H12. I got something like this. Fine. Everyone, is it clear? I have just used this circuit and I have just applied KCL and KVL to get V1 in terms of V2 because I want V1 by V2. This is the ratio that I want. Clear? Or any doubts you have? Okay, so I hope, sir, 1 mark. What is that? 1 MA is not clear. Which can you explain what is 1 MA? I'm not getting it. What is 1
Sir,
mA?
this milliampere,
Okay.
milliampere.
Okay. So V2 by 1 kilo ohm, right? So 1 kilo ohm is nothing but if I take it to numerator, it will be 1 milli, right? So Ix will be V2 into 1 milli, right?
It's 1 millisievert, na, sir.
1 milli Siemens. Okay. Okay. Actually, I should have written in that way. Yeah, you are right. So this will be 1 milli Siemens. So now if I substitute here, it will be 1 milli. So units I have removed. So it will be Rm into V2 into 1 milli. So is this clear?
Yes, sir.
So now I have calculated H12. Now I have to calculate H21. So let us calculate H21. And for H21, what needs to be done? I have to find I2 by I1 and V2 is 0. Okay. So V2 is 0 meaning this will be shorted. So this is shorted. So this is short circuit and this is the current direction I2. So V2 is 0. So that's why we are short circuiting and I2 by I1. What is the input? I1 is the input and I2 is the output. So in this circuit, I have to calculate I2 provided I am exciting it with a current I1. So this is my I1 and this is in this direction and the output is shorted. If you see, say this is ground, then this is also ground. Agree? Because it is short circuited. Agree? Because it is short circuited. So now
Yes, sir.
if that is the ground, then my Ix is basically 0, right? So there is no need to consider this resistor because it is basically shorted. So if this is 0, then this is equals to 0. Agree?
Yes, sir.
Yeah. So now we do not know. So if this is ground and this entire voltage is Vx, so this voltage will be Vx, right? Because they have given that is Vx and this is 0. So the entire voltage is Vx. So this node will be at the voltage Vx. Agree? So now we'll apply KCL at
Yes, sir.
Vx. So let us assume the direction of the currents. So I'll assume current is flowing like this and current is flowing like that. So current entering is equals to current leaving. So current entering is I1 is equals to current leaving in 1 kilo ohm will be Vx minus 0 by 1k plus again in this direction also Vx minus 0 by 1k. So my I1 is 2Vx by 1k, right? Agree? Agree?
Yes, sir.
Yeah. So now if I see, uh,
Yes.
so now if I see as the current in this is 0, whatever is the current flowing here will also flow here because the current flowing in the middle branch is 0. Say this is grounded anyway. So this terminal, say it is G and D. So now apply KCL at ground terminal, G and D ground. So current entering is equals to current leaving. So what is this current that is entering? It is Vx minus 0 by 1k plus current entering I2 is equals to 2 milli Siemens into Vx, right? True?
Yes.
Yeah. So now if I do it, I can get I2 is nothing but 1 millisiemens into Vx, right? Or I can also write it as Vx by 1k, 1 kilo ohm. Here also I can write Vx by 1 kilo ohm. Got it? Yeah. So now what do I want exactly? I want I2 by I1. So H21 is I2 by I1 when V2 equals to 0. So what is this value I2 by I1?
1.
Are you sure you making mistake? I2 by I1. One is 2Vx by 1k, another one
Right,
is
sir.
Vx by 1k. How much? 0.5. Yeah. So we'll get this as 0.5. So I got H21 direct value I got. So H21 is 0.5. Okay. So yeah, this is good. H21 is 0.5. Now we'll see what is H12 and then we'll equate them H12 and H21. So this is my H12 and this is my H21. So what is the condition? The condition is H21 is equals to minus H21, right? So if we do that, sir, please repeat why Ix is 0. So Ix is 0 because we have to find I2 by I1 when V2 is equals to 0. So because V2 is shorted, this terminal is ground, this terminal is ground. So both the terminals of the resistor are grounded. So both the terminals are at the same potential, so no current will flow. Sir, once revise the problem. Okay, sure. So in this problem, they have asked what is the value of Rm such that the network is reciprocal. So now we have seen that reciprocal, one of the condition is H12 is minus H21. So why did I consider H parameters? Because in the next question they have asked what are the H parameters. So I thought of saving time by using H parameters because I can solve both the problems at a time. So first I have written the equation for this and I want to find H12 and H21. For finding H12, I1 is 0, which means this is open circuit. So I have kept it open and the input is V2. So I have excited it with V2 and I have to find V1. So I have to find V1 in terms of V2. So I have done some mathematical manipulation, which is self-explanatory. So I'm not explaining it again. So I have used this circuit and did some KCL, KVL equations and I got a equation in terms of V1 and V2. So from there I got H12 as 1 plus Rm into 1 milli by 2. So once I got this, I have moved to H21, which is I2 by I1 when V2 is 0. V2 is 0 meaning this is short circuited and I have to find I2 by I1, which means I1 is the input. So I have kept I1 as input and I2 is my output. So I have to find I2 and I have to find I1 and I have to find the ratio of these two. So for that to happen, what I need to do, I have to find I2, I have to find I1 and then I have to divide. So I have initially applied KCL here. I got I1 in terms of Vx. Then I have applied KCL over here. Then I got I2 in terms of Vx. Then for calculating H21, I did I2 by I1. So I got H21 as 0.5. Now, what is the condition that needs to be followed? The condition that needs to be followed is H12 is equals to minus H21. So if I do that, I'll have 1 plus Rm into 1 milli by 2 equals to minus 0.5. So now I'll have 1 plus Rm into 1 milli is equals to minus 1. So from here, we'll get Rm to be minus 2 kilo ohm. So Rm is minus 2 kilo ohm. So is this clear? This problem, how we are doing? Or do you have any doubts?
Sir, I have a doubt that
Yeah.
it is in every case H12 is equals to H minus H21, sir.
Yes, only when it is reciprocal. Only when it is reciprocal. Because in the question they have given that.
Sir, here how we can say it is reciprocal, sir?
Huh?
Oh,
They
okay,
have
okay.
given.
Yes, sir. Okay, sir.
Yeah. So now they have asked for Rm. Let us go back and see what is the value of Rm. Rm is minus 2 because they have asked in kilo ohm. Now, if we come back to second question, they have asked with the Rm value that you have obtained, find the H parameters. So we'll do the problem 2. So problem 2 will also come along with problem 1. So we can solve in the same place, but we are basically finding the H parameters. So
Sir, in the previous circuit, how we have selected the ground terminals? Sir,
so
I have seen that. Hmm.
yeah. So in any circuit, if the ground terminal is not given, I am free to select the ground terminal, and I will do the ground terminal selection in a way that it will be comfortable. So if this is the voltage source that is connected, if I consider this as ground, bottom terminal, the top one will be V2. If I consider this as ground, then this will be minus V2, which is not so straightforward and makes my I'll tend to make more mistakes if I consider this as ground, then this becomes minus V2, which is not so good for calculations, because if it is plus V2, then it will look good and I will not make any mistake. So I have considered this as ground, and this also uh, obtained from this voltage source, which is V2. In the second case, anyway, this is shorted. It doesn't matter whether I consider this as ground or this as ground, because both are grounds. You can
Okay.
even consider this as ground and you can still do, but there your calculations become more clumsy, because they have asked 2 ms into Vx. So if this is ground, then this will become minus Vx, because all the voltages are with respect to this terminal. So I have considered that as ground, and it will be very straightforward. Got it?
Yes.
So now they have asked H parameters, right? The second question. So I already got H1, H21 is 0.5. So H21 is 0.5. Now, if we substitute Rm, or we already know H12 is minus H21, so I also got this parameter minus 0.5. Now I have to find H11, and then I have to find H12. So first let us define what is H11 and what is H22. Then we'll know what exactly needs to find to be found in which circuit. So if this is my H matrix, then I can define the H parameters like this. H11 is equals to V1 by I1 when V2 is equals to 0, and H22 equals to, what is H22? H22 is I2 by V2 when I1 equals to 0. First we'll find H11. H11, what is the case? V2 is 0. So whenever the other circuit, the other side is shorted, then we have to find V1 and I1. So in this question, I have to find V1. What is V1 again in this question? V1 is this voltage, right? Plus minus V1. Agree? The 1 and 1 dash terminal is V1, right? Do you
Yes.
agree? Yeah. So now if
Yes, sir.
V1 is the terminal, I know that V1 is equals to Vx. So if V1 is Vx, what do I need? I need V1 by I1, which is Vx by I1. So now I will get my H11 is equals to Vx by I1. So what will be the value of H11? H11 will be 0.5 kilo ohm. Agree? From
Yes.
this equation only I'll get. So H11 is easily obtained, and I got H11 to be 0.5 kilo ohm. If you see, H21 and H12 are dimensionless, and this has a dimension of resistance. Why? Because the way they are defined, that decides the dimension. And let us go back and check. H11 has resistance, and these two are dimensionless. Now if we find H22, it will have the unit of conductance. So H22 is V2 by I2 by V2 when I1 is 0. So let us come back and see what is the H22. So H22 is I2 by V2 when I1 is 0. So it says I1 is 0. So we have to go to the initial circuit, and then we have to find I2 and V2. So in this circuit, I have to find I2 in terms of V2. So that will give me what? That will give my H22. So I have to find, because my input is I2, I have to find what is my I2. Right? Agree?
Yes.
Yeah. So now say this current is I3 and this current is Ix, then this current will be what? I3 plus Ix. True? By applying KCL.
Yes, sir.
So now if I consider this as some node N1, if you apply KCL, then I'll get my I2 to be 2 millisiemen
I3 plus
into Vx plus I3
Vx
plus Ix. Right.
plus Ix.
So now let me take this to the bottom. So now I have my I2 as this, and I also have my Ix as this. This is my Ix, and I have to substitute I3. I3 also I have. I3 is V1 minus this, or I3 is V2 minus V1 by 1K. But I also need V1, which is, so what can I do is, Ix is there. So I'll get this in terms of I2 and V2 because I need basically in terms of I2 and V2. So now I have to substitute I3 also in terms
Yes.
of I1, sorry, I2 and V2. But if I substitute this I3, then I have to also see what is exactly being done over here because V3 is there, V1 is there. And then I can use this equation to substitute my V1 back. So now first let me calculate and see what is my I3. Right. So my I3 is V2 minus V1 by 1 kilo ohm. Agree? So if I calculate my V1 over here, V1 is nothing but 0.5 V2 plus Rm V2 into 0.5 milli. So if I substitute that, what will I be getting here? I'll get 0.5 V2 minus Rm V2 into 0.5 milli by 1 kilo ohm. Right? This is my I3, agree? All of you? I have just substituted this V1 in this equation. So basically what I did is I have substituted this equation here. So then I'll get my I3 in terms of only V2. Clear? Or do you have any queries? Anyone? Any queries? Or is that clear? Or say something? Any doubts? Hello?
Yes.
Yeah. Clear? Or you have queries?
Clear, sir.
Okay. So now we have all the equations. We just have to back substitute it. So now my I2 is equal to 2 millisiemen into Vx. What is my Vx? My Vx is my V1, right? Vx is equals to V1. So I have to substitute the value of V1. 2 millisiemen into V1 is 0.5 V2 plus Rm V2 into 0.5 milli. So this is my first term, 2 millisiemen into Vx. Now I have to add I3. So I3 by 1 kilo means 1 millisiemen into 0.5 V2 minus Rm V2 into 0.5 milli. This is my second term. And what is my third term? My third term is Ix, which is 1 millisiemen into V2. Right? So I have just correlated the entire thing. So LHS is I2, RHS is V2. And what is my value? What is my value of Rm? The value of Rm is minus 2 kilo ohm. So here Rm is minus 2 kilo ohm. Clear? until this point? Is it clear until this point how we are getting this big expression from this by substituting this?
So please repeat this one, sir. I2 is equals.
So I2, first I have applied KCL over here. So my I2 is nothing but I3 plus IX plus this current, which is 2 millisiemens into Vx. So my I2 is 2 millisiemens Vx plus I3 plus Ix. So first of all, I3 is obtained as V2 minus V1 by 1 kilo ohm. And in my previous calculation, V1 is found to be this. So I can calculate V1 to be something like this. And if I back substitute this V1 here, then I'll get my I3 in terms of V2 something like this. So my I2 can be written as 2 millisiemens into Vx, and Vx is nothing but V1. So if I substitute this V1, 2 millisiemens into V1 is 0.5 V2 plus Rm V2 0.5 milli. And I3 is 1 kilo ohm, I can write it as 1 millisiemen. So 1 millisiemen into 0.5 V2 minus Rm V2 into 0.5 milli, which is this expression. And then my Ix is nothing but V2 into 1 millisiemen. So which is what I have written here. But I also know that Rm is minus 2 kilo ohm. So that part needs to be substituted, right? So if I individually calculate this, RMV2 into 0.5 milli into 2 kilo is minus 1. 0.5 V2 minus 1 is minus 0.5 into 2 milli is how much? Minus 1 millisiemen, right? So this is minus 1 millisiemen, right? I am just substituting and simplifying it. And this one will be how much? Minus 2 into 0.5. So it is plus 1 and plus 0.5, it is 1.5 millisiemen. And the last one is 1 millisiemen into V2. So 1 millisiemen into V2. This is 1.5 millisiemen into V2. I have just substituted and simplified. Is that clear, or do you have any queries? Is this clear?
Okay.
I have just substituted this and simplified. It is just mathematical calculation.
Yes, sir.
Is that clear?
Yes, sir. It's clear.
Yeah. So now I have to find H22, which is I2 by V2, right? Which is I2 by V2. And I2 is nothing but minus 1 millisiemen V2 plus 1.5 millisiemen V2 plus 1 millisiemen V2, which means this and this will get cancelled. So it is 1.5 millisiemen. So this is my H22. So 1.5 millisiemen is my H22. So I also got this as 1.5 millisiemen. So now if I write the H matrix, be careful with the dimensions. So H11 is 0.5 kilo ohm, or maybe I'll use orange color, or maybe I'll use a different color, blue. 0.5 kilo, and H12 is minus 0.5, and H21 is 0.5, and this is 1.5 millisiemen. So this is my overall H matrix that they have asked in the problem number 2. Is this clear? This second part? Any queries? First, let us check whether the answer is correct or wrong. So they have asked in millisiemen or kilo ohm. So it is 0.5 minus 0.5, 0.5, 1.5. 0.5 minus 0.5, 0.5, and 1.5. So we have to either write in millisiemen or kilo ohms or scalar values as applicable. So we have to remove this kilo ohm in terms of kilo ohm. So it is 0.5 minus 0.5, 0.5, and 1.5 as they have asked in kilo ohms or millisiemen. So that's why we have to write in that way. So is this question clear? The second question. So in this question, we have basically understood how to find the H parameters as well as how to use the reciprocity final, what do you say, the result to check whether the circuit is reciprocal or not. But in the question only they have given the circuit is reciprocal. So there is some unknown in the circuit which we have to find first, and using that unknown, we have to find the H parameters. So now in this question, see if I don't solve the reciprocity thing in H parameters, again I have to find all the H parameters, right? But in this question, if you see, two parameters I have already obtained, and the other parameter which is H11 is also directly obtained from this expression. So the only time I have spent is calculating H22, and that also it took some time because the calculations are a little bit lengthy. So I have to spend some time to find that one parameter in this H matrix. So that's why I have chosen H parameters, because the other parameters, it saves some time. Sir, in the final exam, we will have only MCQ, or we may have to enter the numeric values in blank spaces. So whatever type of questions that are asked in the assignment, similar type of problems can be asked in the final exam. So if you see nodal analysis, mesh analysis, and then two parameters. So in the entire 4 weeks, there are situations where you have to enter matrices in the answer. So if any question is asked in the final exam from these 3-4 topics, say two parameters, two port parameters, nodal analysis, mesh analysis, there can be questions based on like there can be questions which can be asked from the matrix, and then you have to enter the matrix. Okay, in this year assignment all are MCQ, then it will be MCQ. So whatever type of questions are asked in the assignment, you can expect similar type of questions. So if they are asking MCQ, then you can expect MCQs in the final exam. If they ask matrices, then you can expect matrices. As I'm solving 2018 year assignment, at that time matrices are asked. So maybe at that time in the final exam also matrices might have been asked. So that completes our question 1 and question 2. Question 3 is also similar. The two port parameters are that this two port network is reciprocal, determine GM. And if you see the next question, they are asking G parameter. So here you use this condition, which is G12 is equals to minus G21. And same way here we have calculated H parameters. There we'll calculate G parameters and use that first to find GM. And once you find GM, find the rest of the parameters. So it is a similar problem. So that's why I'm not stressing it much. So is that okay if I skip, because there are few problems where it is actually critical, and we have to thoroughly understand how to solve, or because this question seems tricky, but it is very simple. Only if we understand the concept. So I have skipped that part where they have given the reciprocal network, and they are asking to find the G parameters. So now we'll go to our problem 3 of today's session. Okay. So this will be our today's session problem 3. So any questions till this point? Do you have any queries? Anything you'd like to add or anything you'd like to say? No queries? No questions? Hello?
No,
Are you
sir.
there? Okay. So in this question, if you see, they have given one two-port network, and at the input side, they have 10 volt and 1 kilo ohm, and at the output side, they have 2 milliampere and 1 kilo ohm. So now they are exciting at the output, saying it is having a current source 5 milli, and they're asking what is the value of Vx. So one result that you have to keep in mind, any two-port network with resistors is always reciprocal. So this proof sir has explained in the his theory. So that's why I'm not going into the proof. So any two-port network with any two-port network with resistors, and they can be excited with independent voltage or current sources. So in this, if you see, the entire network is resistors and they are exciting it with either a voltage source or a current source. Any two-port network with resistors is reciprocal. So now we know that this system is reciprocal. So now we have to use what? We have to use the reciprocal these results to solve this problem. So we know that if a system is reciprocal, we'll have this four results, or what do you say, four parameter relationship. So we have to use this or this. So in any question, only one will be used, but we have to know which one we have to use. Okay, so I can use this, I can use this, I can use this, I can use this. But for the given circuit, only one of them might actually fit into this question, because they are exciting it with a voltage, and in another case, they are exciting it with a current. Right? Agree? Or do you have any doubts?
Yes,
So
sir.
any idea like which parameters I can use here, or what do you think?
So can we use Y parameters?
Yes, yeah, that is a very good thought. So we can use Y parameters. So now we'll go into the Y parameters and see what are Y parameters. So yeah, that is one good way of doing. So we'll see in Y parameters, current is the output and voltage is the input, right? So maybe we have to reframe this problem, but this is our initial thought. So current is the output and voltage is the input. So if we consider this part, this is very clear, right? So now I'll try to reframe this diagram, and I'll write in a way that we all can recognize. Again, there is less than a minute. So if this meeting ends, kindly join. This is very important question. It is not so straightforward, but it is very simple. So as one of you have said, we will try to redraw this. There is less than a minute, so this meeting might end at any moment. Okay, and so I am redrawing the circuit in this fashion. Okay, this is 1 kilo ohm. This is also 1 kilo ohm. So they have given this as 10 volt and this current as 2 milliampere. Got it? A and A dash and B dash. So now this becomes my new two-port network. Right. So this entire thing is my new two-port network. I can do this, right? Is this clear? I have just redrawn this original left side figure. So this is our A. Whatever A they have given, I have redrawn it. Right? Clear? Everything? Any queries? Because this is very, very crucial. We are just transforming that circuit into some circuit which we can recognize. Any doubts? Please ask if it is not clear, because this question is very, very conceptual, and similar question you can expect in your assignments also. I have just redrawn this circuit in a way so that it will have two parameters. I mean, two ports. One is the input V1 and another one is the output I2. Clear?
Sir, how can we conclude that which parameters are going to apply to the
Yes,
so we
that
have
is
given their Y
also,
parameters, no, sir?
yeah, good question.
Yeah, how can we conclude that?
Yeah. So someone said Y parameters, but how will we get to that point? So if we see, first of all, we have understood that any one of this can be used because the system is reciprocal. So now we'll see Z12, Z21. So Z12 is what? Z12. So I have to go back. Z12 is V1 by I1, sorry, V1 by I2 and V1 by I1. So in the case of Z, it is excited with the currents and voltage is the output, right? So someone might have looked at this and might have seen that voltage is the input and current is the output. So we could proceed with the Y parameters. That is one way. And here if you see, current is the input and voltage is the output. So here it is kind of impedance, right? So we can either proceed with the Z parameter or we can proceed with the Y parameters, but we cannot proceed with like some other parameters because it will be not so exactly like easy. If we take H parameters, we want V2 like I2 or maybe if you consider this as also voltage, then your output is voltage and input is also voltage. So what I'm trying to say is you have to correlate. If I use H parameters, then what is my H12 and H21? So my H12 and H21. So let us go back and see whether we can use those parameters or not. So H12 is V1 by V2 when I1 is 0 or H21 is I2 by I1 when V2 is 0. So we have to see whether we can transform the circuit in this way. But I am exciting it with a voltage V1 at the input, right? So I cannot see anything here. So I cannot use directly H parameters, right? Now I'll see whether I can do G parameters or not. I am exciting it with a voltage V. So my input should be V1. So if you see my G21, it is V2 by V1 and I2 is equals to 0. So if I consider V2 by V1, so then this port and this port are, so now in that case, this is my one port and this is my other port and this is open. So the current entering here is I2 equals to 0 and this is my plus minus V2 and this is my plus minus V1. So we can also proceed with the G parameters. So you have to see whether the circuit that has been given, whether it fits into the parameters that you are trying to find. Else there is no meaning. So is that clear, Hema, whatever you are asking? Because someone said Y parameters and I could directly see output is current and input is voltage. So I said, okay, let us proceed with that. Because I can easily reframe that circuit in a way that it will give me one of the parameters. Is that clear, Hema?
Yes, sir. Yes.
Yeah. So now if you see in this circuit, whatever they have given I2 and input is V1 and output V2 is 0. So this is what? This is my Y21 parameter, right? Y21 is I2 by V1 when V2 is 0. So what is my I2 from this circuit, whatever they have given? Anyone? What is I2?
2 milliamps, sir.
Okay. So now this is where people might make mistakes. So these are the conventions V1, I1 and I2. So now let us go back and now tell me what is I2?
Minus 2 milliamps,
Minus 2
sir.
milli. Yes. So minus 2 milliampere. And what is my V1? 10 volt, right? So now I'll get minus 1 by 5 millisiemens. True? This is my Y21. Are you following?
Yes, sir.
Yeah. So now because I have Y21 and I know I need Y12. So my what is my Y12? My Y12 is I1 by V2 when V1 equals to 0. True? This is my Y12 and this is how much? Minus 1 by 5 millisiemens because of this condition. Right? Agree?
Yes, sir.
Yeah. So now my input is V2 voltage and output is current. But if you see here, they are asking input as current and output as voltage. So what we have to do is we just have to transform it into this way. So this circuit is there, right? So 1 kilo ohm, they have basically broken down into 500 ohm and 500 ohm. So what I'm going to do is the circuit that they have given, I'll just transform it in a way that it fits into my assumption. So on the output side where they have given this current, I'll do source transformation and I'll use the source transformation so that it will fit into the way I want. So this is my circuit. So let me just redraw that circuit. Okay. So first of all, this 1 kilo ohm, let us erase. So that 1 kilo ohm, they have written in terms of two 500 ohms. 500 ohm, 500 ohm, 500 ohm, 500 ohm. Okay. So this is my two terminals A and A dash. So what I'm going to do, I'm going to do V1 equals to 0, right? So V1 equals to 0, nothing but this gets shorted, right? This is shorted. And this is my direction of I1. Agree? Or do you have any queries? I have just written in the way because they have divided it into 500 ohm. I have also done 500 ohm. And now this is my A dash and this becomes my two port network, right? V1 equals to 0, right? So it gets shorted and the current direction I1 is in this way. Any queries?
No, sir.
Okay. So now we'll do source transformation for this. If I do source transformation, what will be the voltage? Voltage will be 5 milli, this is ampere into 1 kilo ohm, which is 5 volt. So basically we are exciting it with a voltage of 5 volt. Agree? Both are the same circuit, right?
Yes, sir.
Yeah. So now if I use this equation and substitute those values, I'll get I1 by V2, which is 5 volt, is equals to minus 1 by 5 milli Zeeman. So that means my I1 will be minus 1 milli ampere. Okay, so I got my I1. So if I got my I1, what exactly are they asking in the question? They're asking what is the voltage minus plus Vx. So they're asking this is minus, this is plus, and they're calling it Vx. So according to this direction of I1, what will be Vx? Vx will be minus I1 into 500 ohms because I1 is flowing from left to right. So accordingly, my Vx will be negative according to the direction of the current. Agree? Any doubts? Because the current is flowing in this direction, this will be at higher potential and this will be at a lower potential. So Vx is negative according to the direction of current that I have assumed. Right? Or do you have any queries?
No, sir.
Yeah. So now if I substitute my I1, I will get my Vx to be 0.5 volt. So if you see, this is a tricky question. This is not a difficult question, nor this is a lengthy question, but it's a tricky question because we have to see that they have given a resistors and they did not even mention that it is reciprocal because any two-port network with resistors is reciprocal. So now once this is reciprocal, we have taken all the four like results or the equations that a reciprocal network satisfies. So now we have to see which is going to be useful. You have to see what is Z12, what is Y12, and we have to see whether that is fitting in this circuit or not. But directly, I can see I2 is given and V1 is given. So voltage is the output, or say voltage is the input, current is the output, which means it's a Y parameter, and someone has pointed out. So it is a Y parameter. So I2 is the output and V1 is the input. So when V1 is the input and I2 is the output, V2 should be 0. So I have uh, redrawn the circuit in a way as if V2 is 0 because it is short circuited and the current is given and input is excited with a voltage. So now this becomes my actual network with this 1 kilo ohm at both at the input and the output. So now I got my Y21 as minus 1 by 5 milli. Note that this current is in the opposite direction to our convention. So this is opposite to our convention. So this has to be taken care of. So that's why we got one minus sign. So now I got Y21, I have to find Y12, which is also minus 1 by 5 because they are equal. And what is Y12? I1 by V2. So it should be excited with a voltage on the right side and it should be shorted because V1 equals to 0. So I have redrawn the circuit in this way so that my network remains same. So whatever circuit that we have considered or whatever the circuit that is considered in the question, the same circuit we have to consider, but we are free to redraw. 1 kilo ohm I have broken down into two 500 ohms and this is shorted, and output I have done source transformation because we want voltage at the output. So now it's the same circuit but only excited with the other way. So from here I can get I1 by V2, which is I1 by 5 volt. It is minus 1 by 5, which is what we are getting from the reciprocal formula or result. From that I got I1, and then I have calculated Vx in terms of I1 and I have substituted V1. We have to see what is the direction of I1. Then we have to write Vx in terms of I1 and then I have substituted I1. I1 may be negative or positive, I don't care. With the convention that I have assumed, I have written Vx in terms of I1 and then I have solved for Vx. So is this question clear? This is very important question and it is tricky. You can expect similar type of problems in the assignments and the final question paper as well. Is this question clear? This is very conceptual and very tricky question. Doesn't take much time once you understand, but in order to solve it, you need to have that full understanding of realizing the question in a new two-port network, and you have to know this rule or this result that in a two-port network with resistors is reciprocal, and you have to know these four results, and you have to know which parameters you have to check, and then you also have to know source transformation, and then you have to change the circuit in a way that you will get the circuit in a way that you want, and then it is just 2-3 lines problem, but the entire thing relays like falls in understanding the concept and using that concept in a right way so that you'll solve the problem in a like fewer steps. So that's why I have selected this problem for today's discussion. Is that clear? Okay, let us check whether Vx is 0.5 or not. So this is 0.5, yeah. So this is 0.5. So problem number 5, it is 0.5. So is that clear? Or do you have any doubts?
Yes, sir.
Clear. Okay. So now we have time to solve only one question. So I'll see whichever votes, like whoever vote for question 6 more or question 7. Okay, question 6 and 7 are same. So you tell me whether we have to solve this question or 6 or 8. Whichever will get high votes, I'll go with that question. 6 or 8. So this is 8 and this is 6. Here we are realizing this in Norton equivalent. Here we are realizing this in two circuits which are connected in parallel. So which one you would like to like me to solve? Both are
Sixth
like
question, sir.
sixth question, right? Okay. Any other votes? If people don't vote, I'll go with 6. Anyone would like to say anything, or should we proceed with this question? Okay,
Proceed, sir.
6 only.
Yes, sir.
Okay. Okay, so this entire okay, let us solve this. So they are asking Norton current and Norton resistance, but we'll solve. So this will become our problem 4 and 5. So this is also very interesting question. Okay, so this becomes our problem number 4. This entire circuit is converted into a Norton current equivalent and Norton resistance, right? So now let us just go back to basics. First of all, forget this circuit, okay? First of all, forget this circuit. We have this AB as output, which is also 2 dash. Okay, that is our circuit. Forget about 10 kilo and 1 volt. First, we'll what the plan is. First, we will simplify this, and then we'll consider 10 kilo ohm and 1 volt. Why I have removed them to simplify this circuit? Because we would like to uh, convert this circuit, and 10 kilo ohm 1 volt are like can be added at the end, and then also they can be considered. But to as of now, to remove like lot of calculations, I have removed them. But eventually, you will see that by removing them, things will get simplified, and you will know why I have done that. So first we have to simplify this in terms of Norton current and Norton resistance, right? So now let me just redraw this circuit. So we have a network which is given in terms of Z parameters, right? And here there is a resistance, and here it is excited with a current. And here I have considered these are my two terminals, 2 dash or AB, say 2 dash, and this is 1 dash. So this is 0.5 milliampere, and this is 12 kilo ohm. And according to the circuit, this is my plus minus V1, and this is my I1, right? Agree? And this is my plus minus V2, and this is my I2, right? Agree? So I have considered this part of the circuit only. So this is what is given in the question. I have currently removed 10K 1 volt, which I'll add at the end. So this is the question, right? Hello, are you there?
Yes, sir.
Yes, sir.
So now for calculating I Norton, yeah.
So that current, that 0.5 current is not going to divide into this 12K ohms, sir.
Yes, I1 is not
Same
0.5,
current will, I1 is not 0.5
not
then.
0.5, yes. So this is
Okay.
getting divided into the resistor as well. So I1 is not 0.5. So this is 0.5. So 0.5 milliampere will be I1 plus this current. So that will slowly get into that. But I have considered everything. I have not assumed that I1 is 0.5, and it is also not 0.5 because there is some current flowing through 12 kilo. I have just considered this circuit excluding this part. So these two are A and B. So these are my A and B. So now you tell me how to calculate IN. Like any circuit, we are applying Norton's theorem at two terminals. How should I calculate IN? Like I have given you a circuit and I asked you to apply Norton's theorem across two terminals. How will I find Norton current? What should I do to find the Norton current? Forget about two ports, some random circuit.
Circuit the A and B
The
terminals, sir.
Thevenin voltage and Thevenin resistance.
No, we are finding Norton current, right? Why Thevenin is coming?
Short circuit AB.
Yes.
Short circuit A and B terminals, sir.
Yes. We'll short circuit A and B, and this becomes my Norton current, right? Agree? Clear? Very simple and straightforward. Agree? This is my Norton current, right?
Yes,
I
sir.
have to short it and I have to find IN. So immediately I know V2 equals to 0 and I2 equals to minus IN. These are the immediate two things that I can write at this point of time.
Yes, sir.
Yeah. So now because I have Z parameters, I can write this in terms of V1 and V2. So I can write it as V1, V2 is equals to Z1, Z2, and these are 8K. I'm removing the ohm as of now because it is like for the sake of understanding only. So I have removed ohms into I1, sorry, I1 and I2, right? Simple. and understandable? Very straightforward, right? I have just written the Z parameters of the two-port network whose input are V1, I1, and output side we have V2 and I2. So I have just written because they have already given this here. I have just written it. That's it, right? Got it?
Yes, sir.
Yeah. So
Yes,
now
sir.
I have to see what is I1. So apply KCL. So apply KCL. Then what will you get? I will get current entering is 0.5 milliampere is equals to current leaving, which is V1 by 12K plus I1, right? I have applied KCL at this. Maybe I'll call this as some terminal 1. So apply KCL at 1. Current entering equals to current leaving. So 0.5 milliampere equal to V1 by 12K plus I1. Simple, straightforward.
Okay, sir.
Yeah. So now I'll write these equations. V1 equals to 8K into I1 plus minus 1K into I2. And then V2, which is 0, equals to 20K into I1 plus 9K into I2. Basically, what I want, I have to calculate my I2, right? So that is what I want. Get it? So now first I will substitute this in this expression. So now from this what I'll be getting? I'll get V1 equal to 8K into what is I1? 0.5 milli. I'm removing units. So 12K plus or minus 1K into I2. Simple. So now what I'll be getting? I'll be getting V1 equals to 4 minus 2V1 by 3 minus 1K into I2. Simple.
Sir, how we got this
So
20K I1 plus 9K
So V1
I2?
equal to 8K into I1 and I1 is what? 0.5 milli minus V1 by 12K. So I have just basically substituted this over here.
Okay, sir. Okay, sir.
Okay. So now after substituting it, I have multiplied. So 8K into 0.5 milli is 4 minus 8K by 12K is 2V1 by 3 minus 1K into I2. So now if I substitute it, I will get 5V1 by 3 equal to 4 minus 1K into I2. Right? So this is another equation. Okay. Now again substitute I1 in this equation. So what we'll be getting? We'll be getting 0 equal to 20K into I1, which is 0.5 milli minus V1 by 12K, and then plus we have 9K into I2. Right. So again simplify it. We'll have 0 equal to 10 minus 20K by is 5V by 3, 4 5s plus 9K into I2. Agree? I have basically obtained two equations from this and I got one equation at KCL. So you need not follow the steps I am following. You just have to manipulate it to find I2. So you have three equations and how many unknowns? Three unknowns are there. So you have to find I2 from these three equations. So you can use your own way, but basically I have just manipulated it and I got this equation. So now I'll substitute 5v1 by 3. So this is 5v1 by 3, right? I'll substitute it here. I'll get 0 equal to 10 minus 4 plus 1k into I2 plus 10k into I2. So from this, can you tell me what is the value of I2? Sorry, 9k. So I have to get basically one equation in terms of I2. I have eliminated V1, I have eliminated I1. So can you tell me what will be the value of I2 if you solve this? Anyone? Yes, 0.6 milliampere, but there will be one minus sign, so it will be minus 0.6 milliampere. We know the relationship between I2 and IN. IN is what? Minus I2. So from here I will get IN equal to 0.6 milliampere. Agree? So I got my Norton current. So for this circuit, excluding 10 kilo ohm and 1 volt, for this circuit I have calculated Norton current. Simple? Simple, right? Or any queries at this point? Yes. Okay. I have calculated IN. Now I have to calculate RN. So how will I calculate RN? What should be done to calculate RN?
Eliminate the independent sources.
Yes. So we have to eliminate the independent source. And they have already given that in this network, there is no independent source because it is only a resistive network. Okay. So now I have to eliminate the independent source. So current source, what we have to do, short or open?
Open.
Open. So this
Okay.
will be open. So this is also gone. Okay. So now this is only 12 kilo ohm and V1, I1 is there. And basically this is the circuit. And what we have to do, we have to find this voltage, right? So I'll excite it. Sir, Rn can't be found by V1 by I2. No, Rn is V2 by I2 because I have to find the resistor at these two terminals, right? A and B. So I'll excite it with a voltage V2 and carrying a current I2. So now my Rn is what? My Rn is voltage across these two terminals, which is V2 by I2. Simple, right? Simple, very simple.
Yes.
Yes. So now, can you tell me what is the relation between V1 and I1 in this case? Note the current direction and voltage polarity. V1 and I1, because I1 is completely flowing through 12 kilo ohm because the current source has been removed. What is V1 in terms of I1 and 12 kilo ohm? Anyone?
So 12 into
12K into I1, right? But kindly note that there will be a minus sign because the polarity of I1 is the other way. So minus 12K into I1. So now I have V1. Now I have I1. So let me again use the same thing. And I have to find V2 by I2. Okay. So this is what is given. So again, I'll just quickly do the manipulation. I have V1 is equal to minus 12K I1, which is 8K I1 plus minus 1K into I2. So from this, I'll get 1K into I2 is equals to 20K into I1. So that implies I2 is 10 I1. So this is one equation that we are getting. Now if we use the other equation, I'll get V2 is equals to 20K I1 plus 9K into I2. So V2 is equals to 20K into I1. So 20K into I1. So I1 should be replaced in terms of I2 because I need V2 by I2, right? So 20k into I1 is what? I2 by 10 plus 9k into I2, right? True? Any doubts until this point? Are you there? Hello. V1 by 12 is equals to I1. Okay, someone has mentioned that, but V1 by 12 is not I1 because if you see, current I1 is in the opposite direction. So we have V1 equals to minus 12k into I1. So I have substituted there. Minus 12k into I1 is equals to 8k into I1 minus 1k into I2. So if I bring this here, 1k I2 equals to 20k I1. So I2 is equals to 10 times I1. And V2 is 20k times I1 plus 9k times I2. Right. So now V2 is 20k times I1 plus 9k times I2. So V2 is 20k into I1 is I2 by 10 plus 9k into I2. Following? Basically, we are using this 8k minus 1k, 20k and 9k. And we have just removed this circuit and here 12k is there. Hello? Any doubts until this point?
No, sir.
Okay. Sorry, I have made a mistake. This will be 20 I1. I'm sorry. So this is 20 I1 and no one has pointed out. So I2 will be 20. So now from this, what is my V2 in terms of I2? Anyone? What is my V2? Ten k I2, right? So from this, R Norton is 10 kilo ohm, right? Agree? Or do you have any doubts? Just small calculation. Agree, right? Simple. Any doubts? Hello, are you following?
Yes,
You are
sir.
not
No, sir.
answering. Yeah. So now I got
No, sir.
Norton current as well as Norton resistance. So now this circuit, because basically first I have manipulated until this point AB, right? So whatever circuit I have manipulated, that is until this part AB. So let us redraw that. So I have a Norton current of 0.6 milliampere and Norton resistance of 10 kilo ohm. So this is 0.6 milliampere and 10 kilo ohm. And basically this is A and this is A dash. Now we'll connect the resistor, which is 10 kilo ohm and 1 volt. So this is our overall final circuit. But this has to be converted in this format. I want one current source and resistance. So what we are going to do is, for this part, we'll do source transformation. Source transformation. So now what I'm going to get? Here we have one current source and one resistance. So this is 0.6 milliampere and this is 10 kilo ohm. So if I do the source transformation, what will I be getting? I'll be getting one resistance and one current source, right? Can you tell me what will be the value of this resistor and current source? What will be the value of resistor? So I have basically doing source transformation for this part. What will be the value of resistor and what will be the value of current? Anyone? Quickly. Anyone? Okay. So this will be our 10 kilo ohm, and this one will be 1 volt by 10 kilo ohm, which is 1 milliampere. So now if I simplify this, I'll get something like this. I'll get so this is my 0.7 milliampere and this is my 5 kilo ohm. So in the given question, whatever I Norton they have asked, it is 0.7 milliampere and R Norton is 5 kilo ohm, because they have asked us to simplify the overall circuit, which is what we have done. Let us go and check. I Norton is 0.7 milliampere and R Norton is 5 kilo ohm. So yeah, today we have discussed two-port network and we have solved a few problems, and I think we have solved 3 to 4 problems, but it's not about the number of problems that we have solved, but about the concept that we have learned and how we have applied it to the different problems. Do you have any questions? Else we'll wind this session.
So how that 1 milliampere, how you go? So that one is 0.1. So it
1
will
volt
be V by
by, oh, sorry. Yeah, sorry. I'm really sorry. Yeah, this is 0.1. There is less than a minute, so if this meeting ends, kindly join back. Any further questions do you have? So that's why it is 0.6 plus 0.1, 0.7 million. And this is 10K, 10K parallel 5K. Any further questions, or we can wind this session? Okay, then if you don't have any further questions, we'll meet in the next week for week 8. All the best for your assignment, and see you in the next week again on Monday 6 to 8. Okay, then good night. Bye.